Okay, ladies and gentlemen, this is Mishler Math again. We're putting the fun in function since 1999. Trying a little bit different approach here. We're going to try using the smart board here today. And function is a relation between two variables such that each value of the first variable is paired with exactly one value of the second variable. The domain is a set of all possible values for the first variable. Range, set of all possible values for the second variable. Another nice way to think about this to start with, a domain is all possible values for x, okay? And the range, all possible values for y, okay? And if you think about that, domain is x, range is y. To start with, that'll help you a lot, okay? So let's take a look at this next one. This is what a function is, okay? Here's a function. Say y equals x squared is a function. Y equals the absolute value of x is a function. And let's see. Y equals 3x minus 2. That's a function. Y equals 4. That's a function. The graph of y equals 4 is a horizontal line that passes through the y-axis at 4. Okay. This, of course, you know, this is just a simple linear equation. Y equals 3x minus 2. Another function we don't think about is a student and their grade. I'll explain that in a few minutes, but a student and his grade, you know, each student only has one grade, okay? So each student has exactly one grade associated with them. And we're talking about the math grade. I know you have a different grade in English and a different grade in Arabic and a different grade in history, but we're talking about your math grade. Each one of you has exactly one grade. Okay. Another way of looking at this is, let's say you got 3, 4, 5 in this collection here, and over here we got 2 and 7. Now the 3 is linked with 2. The 4 is also linked with 2. The 5 is linked with 7. This is a function. Okay. Here's another function. Let's make this one green. 2 and 4. And over here, I've got 6 and 5. So 2 is linked with 6, 4 is linked with 5. You see each one of the input variables, this is the input, or the x if you want. This is the output. Each one of the input is linked with exactly one output. Switch gears here. Not a function. X squared plus y squared equals 5. That's actually the graph of a circle. You're going to see a circle, and that's not a function, and I'll explain why. X equals y squared. That's not a function. That's actually a parabola that goes sideways. Okay? And that's not a function. X equals 4. That's not a function. That's a vertical line, and a vertical line is not a function because x is your input variable, and x has a whole infinite number of output variables, okay, or output values for y. And let's see what else isn't a function. A grade and all the students. Sorry, can't write in there. A grade and all the students, okay? Because a grade can be matched with, if you start with a grade, like for example 93%, you can have 2 or 3 or 4 students with a 93%. If you start with a student, well, you can have 12 students with a 93%, but each student has its own, okay, grade. And so let's look at another one here. These are not functions now. Remember, these are not functions. Okay, watch. 2 and 5. And over here we have 3, 6, and 8. Okay? Suppose 2 is associated with 3, and it's associated with 6. Okay? And 5 is associated with, it's supposed to be, sorry about that. Back up again. 3, what do I have here? 3, 6, and 8. So 2 is associated with 3 and 6. 5 is associated with 8. Okay? You notice that 2 has two different outputs here. Okay? So that's not a function. Look at another not a function thing. 3 and 4. And 7 and 8. Okay? 4 is associated with 7 and with 8. 3 is associated with 7. This is not a function because when I put 4 in, I get two different things coming out. Okay? So this is going to be a little tricky to understand at first, but hang in there, you'll get it. Vertical line test. Vertical line test is used on a graph to figure out whether you've got a function. I told you that the x squared plus y squared equals 5 is a circle. Okay, it looks kind of like that. That's the graph of x squared plus y squared equals 5. Okay? Notice when I put a vertical line through here at any point, at some point here, I pass the graph at two different locations. You see that? Sure, if I put a vertical line through here, it doesn't pass through the graph at all. If I put a vertical line right here, it only passes the graph one time. But I can put a vertical line through here, and I can pass through the graph twice. If I can do that, it fails the vertical line test, and therefore it is not a function. Okay? And another way to look at that is the x equals y squared. Well, that's going to be, I told you it's going to be a sideways parabola. Looks like this. Okay? Well, look what happens when I put a vertical line through here, right here. Okay? That vertical line passes through the parabola at two different points. And so that is not a function. Okay? And y equals x squared. Now that's a regular parabola that we're used to, and it looks like this. Oh, it looks actually much better than that, but this is a slow day for Mishler math here. So, okay, I put a vertical line anywhere on that graph, and it only passes through at one point. Same thing with here we go. This is one we just studied. This is a graph of y equals absolute value of x. Notice I can put a vertical line through here anywhere I want, and it does not pass through in more than one spot. Okay, so let's try the next slide here. A relation is a relationship between two variables so that each value of the first variable is paired with one or more values of the second variable. Okay, so a relation is the same thing as a function, except the relation can be a relation. All these other things we talked about down here, okay, these are all relations. All in blue over here on the right side, those are all relations. If it doesn't pass the vertical line test, x squared plus y squared equals 5, that's still a relation. X equals y squared, that's still a relation. Okay? So it's a relationship between two variables such that each value of the first variable is paired with one or more values of the second variable. Function notation looks like this. F of x. And that's how we say it. F of x equals 3x minus 4. You've been looking at it all this time, as y equals 3x minus 4. You might want to continue looking at it that way, except f of x, the function notation, allows us to do things that we can't normally do. For example, if I'm looking for f at 2, then I put 2 in here where the x is, I say 6 minus 4 equals 2. So f of 2 equals 2. F of 3 equals 3 times 3 minus 4, which is 9 minus 4, which equals 5. So f at 3 equals 5, or f of 3. So we say f of x. That's how we say function notation. F of x. Okay, that's how that is pronounced. F of x. So, the independent variable is usually x, and the dependent variable is usually y. The independent variable, you notice the independent variable is what we start with. Okay? We say f is a function, or y is a function of x, or f of x is a function of x. Okay? In other words, whatever this is dependent on what x is. So if we want to find a value, we start with x and we end up with a y. And another way of looking at this, which really is helpful, and that's a function is a kind of a machine. Like, for example, if I say f of x equals x squared. Okay? Well, I put x in here. Let's say I put in x equals 3. Well, I put that into my function machine, and it goes through this little equation right here. And what do I get? I get my dependent variable, f of x, y equals 9. If I start with x equals 3, then y equals 9. Or f at 3 equals 9. Okay? So that's how that works. And finally, let's take a look at a couple. Here is a function. Okay? This is a function. And the reason is because, look, each x value has only one corresponding y value. You see that makes up an ordered pair, 2 and 5. The domain of this function is 2, 3, and 4. Those are all your possible x values. The range is 5, 6, and 7, all your possible y values. That's a function. What about this one? Is this a function? Think about it. Your domain is 3 and 5. 4 is, even though it's shown there, it's not part of your domain because it doesn't have anything associated with it. Okay? So your range is 6, 7, and 8. Notice I've got input 3 in and 6 and 7 out. So I got the same input and two separate output values. So that means it is not a function. Okay? Not a function. But it is, of course, a relation. Isn't that a goofy R-A-A-I-O-N relation? Goofy looking R there. Anyway, let's see what else we have here. I think that's pretty much it. That's what functions are all about. And that's all I wanted to tell you. Thank you.